Alrighty, so let's start building a pipeline. So far, we've set up everything. So we've set up your local environment, we've set up your AWS account, and we also spent some time looking at the data set in session 1 during the exploratory data analysis. In session number 3, we're going to start building our pipeline. But before we start looking at code, I'm going to show you what that pipeline is and why do we want to build the pipeline in the first place. I'm going to go here. I'm going to open our notebook here. So I want to have this big chart in front of me so I can go through what's happening here. Why a pipeline? And just to start, we're going to be focusing on the training pipeline. There are multiple pipelines here. You can see there is a training pipeline. We have an inference pipeline. Then if I scroll down, we also have a deployment pipeline, and then we have the monitoring process. But I'm going to focus for now on the training pipeline. First of all, what is a pipeline? Well, this is just a chain of components, okay? So you have a chain where you have component 1 connected to component number 2, and then connected to component number 3, and so on and so forth. Our goal here is to build a system that I can tell that system or that application or that pipeline, I want to be able to configure that pipeline to look at a data set and say, hey, I have a data set located in this address. Go and create a model out of that data set. Now, to create a machine learning model, there are a number of steps that we have to go through. We have to pre-process that data. Like you saw in the previous session, there are missing values. We need to transform some of those features. We might need to discard some of those features because we don't need them. So that will be the first step. We need to pre-process the data. Then we need to train a model. Then we need to evaluate that model just to make sure that the model is actually producing good results. And then we have, or we are going to have a model that we can actually register and say, hey, we have a model that's ready. And obviously down the line, we can deploy that model. But the pipeline is the structure that's going to combine all of those steps and execute them one after the other. And that's what you have here on the screen. So the first step here, and all of those components, all of these components that you have here on the screen, they're going to become obvious as we make progress. But today we are going to be focusing on building, number 1, the pipeline, and number 2, one little step, which is the first step of that pipeline, which is this split and transform step. This step will take the data. See this little green bucket here? That's the S3 bucket where we store our data set. So this step will take the data from the bucket. We'll split that data, splitting meaning we want to take the whole data set and set aside a holdout or held out a test set so we can later validate that that model is actually working. That's what splitting means. And we need to transform it. By transforming, what I mean is just modifying the columns, the missing values, replacing them, fixing them, making sure the data set is clean. We want to do all of that within this component. The output of this component, of this split and transform, we're going to save it back into S3, okay? And then the next step will be training, and then we're going to evaluate the model, and then we're going to run a condition just to make sure the evaluation is successful, and finally we're going to register this model. This is how this pipeline is going to work. Again, today we're going to focus on building the pipeline and adding one step. And as we move forward in future sessions, we are going to start adding more and more steps to our pipeline. By the end, we're going to have a full pipeline that you can just execute and make it work. By the way, this pipeline, even though we're working with like a simple data set, the Penguins data set, this is a real pipeline that you can use in an application in the real world, right? In a production application, right? It's pretty much the same steps. Every system is different, obviously. So there are going to be systems that require more steps or fewer steps, but this is sort of like a perfect template that you can start from when building a production application. So let's go back to the code and let's start building this step by step. So I'm going to go to session number 3, which is today's session. Remember that the whole outline of the cohort is right here. You can get it here in Visual Studio. There is an outline tab. You can also do Command-Shift-O. I think it's Control-Shift-O for those of you on Windows. And this is going to open this little window here where you can navigate. You can type the name of the session, and you can quickly navigate through everything that says Session 3 here. See? I don't remember how this is called, but anyway, it's the symbol view, something like that. So anyway, I'm gonna go to session number 3 and look at this little chart here. This drawing represents just this processing step, just to make sure you understand what we're gonna be building during this step. We're gonna get the data set from S3. Remember, in session number 1, we stored the data in S3. We want to build a processing step, which is the first component, that is going to get the data from S3, okay? This step will transform and split the original data set located in S3, and the output of this processing step will go to the training step that we will build in the future. Our goal today is just to get this processing step working and to capture the output. And here in this chart, you can see that the output that I put here is the train and validation sets, for example. So the data that we're going to use to train a model, the data that we're going to use to validate the model, and I also added additional outputs here. So there are going to be more outputs. We're going to talk about them when we get to that point. This is sort of like the architecture of what we're building today. First step is to create a processing script, okay? So what is this for, and why do we need a processing script? When we are creating a pipeline in SageMaker, every step is going to be running in the cloud, okay? And every step, what we usually do is to provide a script, a Python script that's going to do the job that the step needs to do. In our case, we want to create a processing step that is going to process a set of inputs to give us a set of outputs. But how the processing will happen, that we need to define. And we define that by creating Python code that will do the data cleaning, will do the splitting, will do the transformations, all of that we want to do. Then we're gonna tell SageMaker, here is our script, please execute that in your processing step, and SageMaker will take care of doing that. That's why we need to create a processing script in the first place. Now, how do we create a processing script? The first cell here creates a folder inside the code folder. Remember in session 1, when we were setting up the environment, we created this code folder where we are going to store a bunch of stuff that we need, including the scripts that we are going to be executing. So I'm going to be creating a processing folder within the code folder. I'm making that directory if it does not exist. And then I'm adding that directory to the system path so I can later import that script and test it out. You're going to see that in a second. Now, here is my script. This cell contains my script. And I'm going to go line by line and explain what I'm doing in this script. It's decently long. It's like 201 lines long. But before I go line by line, I want you to focus on this first line here. It says write file and the name of a script. So this is what happens, and this is a very, very common question that I get. People usually say that in production applications, Jupyter notebooks are not useful, or that you should not deploy Jupyter notebooks. There's a common saying, a common joke, that you should not deploy Jupyter notebooks. So let me explain what that actually means. So Jupyter is a great way to write Python code, but it's usually focused on exploring, on help you explore data. So the advantages that Jupyter provides are not useful when running, let's say, a script in a production application. So you don't get any of those advantages there. Like they don't matter. And Jupyter, on the other side, it promotes certain practices that are great for data scientists to do when exploring data and testing things out and writing experiments, but are not necessarily great when running in a production system, right? When you just want something to happen in a production application, those practices, that way of organizing the code is not necessarily the best way of doing that. Therefore, for years, we've said, well, Jupyter Notebooks, you don't run them in production. They're going to be inefficient, right? They're going to have, it's just not going to be a great way of doing that. And therefore, people just translate whatever is in a Jupyter Notebook into a script that they can actually execute in production. A few years ago, Netflix came out with a paper or a blog post, I think both, where they talked about a tool that they built to run Jupyter Notebooks directly in production. So they built this tool that pretty much makes running Jupyter Notebooks feasible in production applications, because any potential disadvantages of running a Jupyter kernel, they were gone with this tool. This tool allowed them to run these Jupyter Notebooks like they were a script. And obviously they had to write, their developers had to write Jupyter Notebooks following conventions just to avoid any problems with, what I mentioned before, all of these practices that are not necessarily great for Jupyter Notebooks. What I'm trying to say with this is there is actually a way to run Jupyter Notebooks in production and make so efficiently. But that's my point, is not to tell you that that's what I'm doing here. The reason you see this white line at the beginning of this file is because all of the code within this cell I'm not executing directly. I'm using a Jupyter Notebook here as the interface for me to write a Python script, a regular Python script that will run in production. Let me create a new cell so you get the idea here. In this new cell, I'm gonna print hello world. If I execute this cell, you should get back hello world. So this cell executed and we just printed hello world. Now I'm going to copy this line. I'm going to paste it here. And now notice what's going to happen. When I execute this line, I don't get hello world anymore. Instead, I get a line saying overriding code processing script.py. If I go to that path and I open script, you get the content of that cell. So this cell magic, that's what's called, is telling Jupyter to not execute this particular cell. Instead, to take all of the content of this cell and save it to a file. So what I'm doing here as part of this program is I'm using my notebook as an interface. I'm writing Python scripts and I'm saving them to separate files. And those are the files that I'm going to be running in production applications. And the reason I mention this is because some people say, but why are you writing all of your code on a Jupyter Notebook? You're not supposed to do that in a production application. I'm not. I'm just using Jupyter to create those files. But I also wanted to mention that, yes, you can run Jupyter Notebooks in production applications as well, even though I'm not doing that here. You should also be able to do that if you use the right tools and follow the right conventions. Hopefully that's clear. This is my script, the script that I'm writing. Let me just execute or re-execute this line. And let me see. If I go back to the script, you can see this is just a regular Python script. Let's go line by line and make sure I explain everything that's happening here. So the entry point of this file, remember, this is the script that I'm going to tell SageMaker to run as part of my pipeline. When I execute the pipeline, this script is the one that SageMaker is going to execute. And the goal of this script is transforming and splitting the data set. So let me go to the entry point of the script. This is the entry point of the script, okay? And it calls the preprocess function. It calls preprocess and it passes a base directory, where that base directory is a directory that's going to be pointing at, when SageMaker runs my script, it's going to have a container, a Docker container. And inside that Docker container, in this folder, that's the base directory. So SageMaker is going to save all of the input data relative to this base directory. So that's what I'm passing here. I'm going to call preprocess. And if I go to preprocess here, let's see what's going on. All right, so this is preprocess. So what is the first thing that I'm going to do? Well, I'm going to read the data from input files, okay? So I'm calling this function read data from input CSV files, and I'm passing the base directory. Let's go into this function and see what I'm doing there. Here is the function. You know already what's going to happen in the function. I just want to go line by line to make sure it's clear. So I'm going to an input directory. So relative to the base directory, there's going to be an /input directory. I'm going there and I'm grabbing every single CSV file within that directory. This allows me to have my data set split into multiple files, right? As scientists collect more data, they're gonna keep sending more files, more CSV files, and I can just drop them in that folder and have my pipeline process all of that data. I don't need to just create a massive CSV file. I can have it chunked out into multiple files. So I'm gonna read them all. If there are no files, I'm just gonna raise an exception. Hey, there's nothing here for me to process. But if I do have files, I'm then going to create an array with all of those files. So I'm gonna be reading them with pandas, loading them in memory, creating an array with all of these panda files, and then concatenating all of these files in memory into a single data set. At the end of this line here, I'm going to have a data frame that contains all of these files into a single data frame, into a single file in memory. And then I'm going to return a shuffled version of this data set. So shuffle the data, I added the comment here because it's not obvious. When you say sample and you pass those arguments, basically what you're doing is take my data and shuffle it and return it back. And I want to do this every single time that I run my pipeline, so I don't get the same chunk. I don't get the same order every time. That's gonna be helpful when training the model. All right, so this is what I do here. So let's go back to the preprocess step, or the preprocess function. I read my data, and then here I'm going actually a little bit more. Up to here, I'm gonna be creating or preparing a scikit-learn pipeline. Now, I don't want you to get confused here. We're talking about two different pipelines, and I'm sorry I have to use the same term, because in machine learning engineering, we use the word pipelines for everything, okay? In this case, I'm gonna be creating a scikit-learn pipeline to transform my data set. That's what I want to do. I'm talking about we're working on a bigger pipeline, a SageMaker pipeline, to run the end-to-end process, pre-process the data, training, evaluating, registering. But this inside the pre-process step, there's going to be another pipeline. This time is a scikit-learn pipeline that will transform and clean my data. What do I need to do? Well, the first one is I'm going to create a column transformer, okay, for the target column. The target column is species. We want to transform that column because we want to turn it, as you can see, remember, species was a categorical column. We want to replace the categories by just an ordinal value, 0, 1, and 2. So instead of dealing with Adelie, Gentoo, and Chinstrap, we want to deal with 0, 1, and 2. And, you know, this is probably obvious after watching the live sessions. I talked a lot about encoding and turning categorical columns into numbers, but models don't like to work with categories or with categorical columns. They prefer to work with numbers, most models at least. In our case, we're gonna be building a neural network, so I don't want to deal with categories or categorical columns. That's why I'm transforming my categorical columns into numbers. So this transformer, when I use it, will turn the column species, that's what I'm specifying here, using an ordinal encoder, okay? Starting on 0, 0, 1, 2. That's what's going to happen, okay? Then I have a numeric transformer, and this is gonna get applied. I'm gonna apply this numeric transformer to every numerical column in my data set. And there are two things that are going to happen here, okay? Remember, or look at this. This is a pipeline, so I'm just adding multiple steps. So for my numerical columns, first I'm going to impute any missing value. Remember that we did that in the last session. We imputed missing values using the most frequent value on that column. Well, here numerical values, I'm going to impute using the mean, the average of that column. So if there is a missing value, I'm going to compute the average of a column, and let's say the average is 42.5, and I'm going to replace any missing values on that column with 42.5. And then I'm going to scale the values. And in the live sessions, we also talked a lot about scaling or standardization. This is just going to use a standard scaler, so it's going to take my values, the 48 and the 30s and the 20s, and it's going to squeeze them into a very small range. And the reason we do this, without going into too many details, because I'm covering that in the live sessions, is because we want our neural network, our model, to work with small scale and have the same standard scale across all of the features. So if we have 5 numerical features, we want our neural network to, for every feature, to work on the same scale. We don't want values in the thousands and other values in the tens. We want all of those values across the same scale. So in this case, I'm going to, again, imputing missing values, then scaling those values to be in a small range. Then there is another categorical transformer, okay? So we have a target transformer that's going to focus on the target column, a numeric transformer that we're going to apply to numerical columns, and then we have a categorical transformer that we're going to use for any categories in our data set. It's also a pipeline. First, we're going to impute any missing values using the most frequent value on that column. We already talked about that. And then we're going to encode those categories using one-hot encoding. The live session talks about one-hot encoder. Just to keep it simple here, basically instead of working with text, I'm going to be turning every category into like a binary value that's going to be, let's say we have 3 values for 3 islands. Instead of using 0, 1, and 2 for the islands, that will be an ordinal encoder. I'm going to be using 001 for the first island, 010 for the second island, and 100 for the third island. And again, the live sessions go into details about the one-hot encoder. I already have these 3. Now I'm going to sort of like put them together. I create something that's called the features transformer. It's a column transformer. And look how this is going to work. I'm going to say, okay, for anything that's numeric, or the name numeric is the name of this transformer, apply the numeric transformer for any columns that are not objects. So categorical columns, scikit-learn says they are objects. So anything that is not an object, they're going to be numbers. Apply this transformer here, which is our numeric transformer. So what's going to happen is that it's going to go through all of the columns. It's going to say, are you an object? No. Then I'm going to apply this to you. Are you an object? Yes. I'm going to skip you. Are you an object? No. I'm going to apply this to you. And then the categorical transformer is going to get applied to the island column. Something interesting here. The sex column is also a categorical column, but I am not applying it here to the sex column. So when I run this features transformer in my data set, what is going to happen is that the sex column is not going to be transformed at all. So what scikit-learn does is, because I'm ignoring the sex column, scikit-learn will get rid of that sex column. The reason I'm not using the sex column to build my model is because sex does not have any predictive power in this example. And I'm going to let you, as an assignment, I'm going to let you figure that out, why that's the case. But because sex doesn't help me determine what the species of the penguin is, I'm just going to get rid of it. Fewer columns is much better, okay? So you want to get rid of any columns that don't have any predictive power. So this, the way I'm removing sex from the list, is just by ignoring it, by not applying any transformations to it. So this transformer will get applied to every numerical column, and this second transformer will get applied to any categorical column in this particular list, which is just island. So sex is gonna get outside. All right, so this is the definition of my transformations pipeline. Let's keep going down the list here, or down the code. Line 54, what I do is I split the data. And it's very important that we're splitting the data before transforming it. I think I talked plenty about this in the live sessions, but this is key, okay? So let's go inside split data. Let's go inside this function here. I'm using the train test split scikit-learn function. So that's a function I pass what the original data set is and what the test size is going to be. And it's just going to do the splitting for us. Remember, we do the splitting because we want to keep some data aside to validate and test our model. In this particular problem, I want to have three sets. I want to have the train data that I'm going to use to train my model. I want to have a validation data that I'm going to use to improve that model. So as I'm training the model, I want to experiment. I want to change different hyperparameters to improve my model. I want the validation data to help me understand whether the changes that I'm making to my model are actually improving my model. And then I want a third set, which is the holdout set, or called test set, which I'm never going to look at. I'm only going to use to finally evaluate the model at the end. When I'm done, I'm going to use that test set to evaluate the model. That is what I'm doing here. Now I'm using the train test split twice so I can get three sets out of the big set. So the first line takes the whole data and splits it in 70% and 30%. How do I know that? Because it's 0.3 the test size. So the train set is going to get 70% of the data. The temp variable is going to get 30% of the data, okay? And now I'm going to split that temporal variable. And I'm going to split that temporal variable in half. So now the validation is going to get half of 30%, which is 15% of my original test set. And the test set is going to get half of 30%, which is 15% of the original test set. At the end, I'm going to have 70% of the data is going to be used for training my model, 15% to validate that model, and 15% to test that model. And then this function is going to return all those three sets, okay? So going back up, that's what I get here. Now I'm gonna do a couple, or I'm gonna call a function with a couple of things, and this is going to help us when we get to monitoring. I'm gonna explain what they do really quick, but you shouldn't worry about them for now. When we get to monitoring, this is gonna become important. I'm basically saving what I call train and test baselines. Before doing any transformations to the data, I want to save a copy of those files and get them out of my processing job as outputs, because I'm gonna need those original raw data files to do monitoring. So these two functions, what they do is just saving those sets into the list of outputs into a folder that will be used to compute the outputs or to determine the outputs. I'm saving a copy of those sets there. That's what's happening here. It's time to transform the data. Notice, remember, we first split the data, then we transform it. You should not do it the other way around, because you're gonna be leaking information from the train data into your, from the test data into your train data. So this is how you apply now the transformers. I'm gonna start with the target transformer, okay? So I'm gonna fit transform. So basically I'm using the transformer. Remember, just as a reminder, this is the target transformer, which is focusing on the species column, or column 0 of my list, right? It's focusing on that column. And I'm applying the target transformer. I'm applying it to this set right here, which is the train set. Species.values. And the NP array is just a transformation to shape the data into the format that the transformer expects. So you shouldn't worry too much about that. You can play out on a separate cell with what the reshape -1,1 does. It's just basically shaping it into the format that the fit transform expects. That's what happens. But here is the key. I'm calling fit transform here. there are two operations that are happening. The first operation that's happening is a fit operation. So any pipeline, any scikit-learn pipeline, when you call the fit method, what it does is it's going to look at the data and it's going to save the global statistics of that data. In our case, we're looking at the target column, the species column. So what is one potential global statistic? Well, it's how many different values do we have on that column. In this case, it's 3 values. So it's going to store that information. And this transformation is going to be an ordinal transformation. Remember, the target transformer applies an ordinal encoder. So that means that the fit operation is going to say, we have 3 categories, Adelie, Gen2, and ChainStrap. And I need to assign an ordinal value to each one of them. I need to replace them with an ordinal value. So I'm going to assign, for Adelie, I'm going to assign value 0. For Gen2, I'm going to assign value 1. And for ChainStrap, I'm going to assign value 2. That is what the fit transformation is going to do. The fit, function is going to do. And then I'm going to call transform, is fit transform. When you call the transform, that is when you go to the data and actually make the changes. So anytime it finds Adelie, it's going to replace that value by the number 0. Anytime it finds ChainStrap, it's going to replace that value by the number 2. Why are these two operations separate and why that is important? Well, you will see that after applying this to the trained data, I'm only going to call transform, same transformer, but now I call transform on the validation data. I'm not calling fit again. So what's happening here is that I'm fitting my transformer on the trained data and using the same findings, the same global statistics that I found, that I computed on the trained data, I'm using that to apply on the validation data. Why is this important? Well, here is just a quick explanation or a quick example of why this could be important. Imagine that I'm going to create a new column here. Imagine that I have a column or a data set with the data is Adelie, and this is the first column. Okay, so the first column of my data, the first row of my data is an Adelie penguin. The second row of my data is a ChainStrap penguin. And the third row of my data is a Bisco penguin. Okay? So when we fit a transformer on this data set, the transformer is going to say, okay, so we have Adelie, and that's going to be 0. We also have ChainStrap, and that's going to be 1. And we have Bisco, and that's going to be a 2. Okay, so these are the values that the fit operation is going to do on my first data set. But then I have a second data set, which is the validation data set. And let's say my second data set only contains Adelie and Bisco. That's it. That's the only data that I have in my validation data set. If I fit on the validation data set as well, the map will look very different. This is what the map will look like. See how on the train set, Bisco is number 2, gets replaced by number 2, but then on the validation data, Bisco will get replaced by number 1, because there is no data in the validation data set containing ChainStrap. Or even if there is, there might not even be in the same order. So that is why it's important that you fit on the train data, and then you apply the transformation on the validation data. So when processing the validation data, we're going to be using these global statistics that we computed on the trained data before. That is how you avoid any data leakages or any problems when you're processing your data. You only fit on the trained data and you reuse that everywhere else that you need to apply the same transformation. Hopefully that is clear. Let's go back here to where we were. Okay, so we were transforming here. Notice that this transformation, calling the fit transform and the transform then for the validation and test, they all return a single array, which is just the target values. And I'm just storing those in a variable that starts with a y value. And this is just a convention, weird convention that people in machine learning use. anything that has a Y, that means the target value. And the convention comes from, the traditional formula of the line. So Y, which is the target value that you're looking for is capital X, indicating a matrix of features. And then W, which is the weights. Actually, this should be a matrix of weights plus a bias. Yeah, it comes from that. Anytime you see Y, that means the target column. So Y train, that is a column containing every target value of the train data. Y validation, every target value of the validation set, etc., etc. After these three lines, we already transformed our target columns. Now we need to transform the rest of our data set. Before we do that, I'm just gonna drop the species column because we already transformed it. We don't want to transform the species column because it's not a feature, it's the target. So these three lines are just gonna drop that column from my data. And now I'm going to apply the features transformer, right? Which is this one that we created here. We're gonna apply this features transformer to the data set, now without the species column. It's the same process that I did before. We first fit and transform the transformer or the data. We fit the transformer and transform the data, and then we only transform the other two sets using the same global statistics we computed before. After doing this, and notice how I'm using capital X train, capital X validation as a convention to indicate X's are features, Y's are targets. Okay, after doing that, I'm calling save splits. Okay, so let's go to this function here. And this does what you would expect. It would basically go put together, concatenate the features back with the target column. We'll concatenate them both. So now we have like a big matrix, all of the features and the target column for the train, the validation, and the test, and then it's going to save them. Okay, so these three, this is me defining the path of where I'm gonna save each one of those files. This is me creating the directories, and then here I just save those files to CSV files. After calling save splits, I'm going to get three separate directories, each one of them containing one CSV file, one for the training set, the transformed training set, one for the transformed validation set, and one for the transformed test set. Those are the outputs. That's the goal of this whole step. Let's go back up. Let's see what's left. So we saved the splits, and then finally I'm calling something that's called saved model, and I'm passing the target transformer and the features transformer. Let's see what I do here inside and why am I doing this. This function uses joblib to save a file called target.joblib and another file called features.joblib. And then after I save those two files, I created .tar.gc file. It's going to be called model.tar.gc containing these two files. Now, why am I doing this? So here is what happens. When we deploy this model in production, users are going to send us raw data. So the user is going to submit the data of a penguin with the island and the body mass, all of the original data. And before I can actually take that data through my model to generate a prediction, I have to transform that data using exactly the same process that I used during this stage. Not only the same process, but I also need to use exactly the same global statistics. Remember the whole conversation about fit and transform. So in production, when I deploy this model, I need to have those transformers that I already fitted in the train set, so I can reuse those transformers and transform, pre-process the data that the user is sending me. That is why I'm saving them here. That is one of the outputs of my processing job. Okay? And now we're gonna see all of the outputs. You're gonna see the whole list. But part of the pre-processing job is to create or save the transformation pipeline that it uses that I used to transform my data. So that is it. This is what this script does. Again, high level, it goes through the data, it defines a pipeline through all of these, saves the original data, the train and test set, splits the data, saves those baselines, we're gonna see those later, applies the transformations to the target column and to all of the rest of the columns, then saves those splits in disk and saves the transformations pipeline. That is what my script does. This script will be created by a machine learning engineer, or this script will be created in collaboration, or a machine learning engineer in collaboration with a data scientist. They will sit together and will create this, hey, how do I transform this data? This is what you do. Now we need to set this up as part of a pipeline. We need to run this script. We need to tell SageMaker, take this script and run it as part of a pipeline, run it in the cloud. Let's see how we do that. Let me close here. Let's go down. So this session here, by the way, the hello world was still there. So this next cell is testing my script using PyTest. You're gonna notice here that I'm importing IPyTest, and this is a very cool library that I found that creates a cell magic, so I can use it as part of a Jupyter notebook. And anything that's here inside, Jupyter is going to run using PyTest. So it's just gonna run as a regular unit test. I created a few unit tests here for you, just so you get used to them. It is really, really important to test your code, especially in these cases where your code is gonna be running in the cloud. You really don't want to create a development cycle where you test your stuff in the cloud. It's not only more costly, but it also takes a long time to wait for a process to start in the cloud and return with a problem. It's much better if you test all of your code beforehand. So anyway, I'm creating here, anytime you see this IPyTest, that means that everything inside is just gonna work as a PyTest unit test. I'm creating here the code to execute there. You're gonna see, like, for example, this test, it tests that the pre-process step generates data splits. So I'm basically just listing the directory, the output directory, and checking that there should be a train, a validation, and a test directory inside the output directory. These tests that I'm generating the baselines, these tests that I'm creating the two models, the features and the target model. Again, I'm not gonna go through line by line through all of the tests, but you can see I added a bunch of them here. There are 8 of them that you wanna make sure they passed before anything else. If they don't pass, if they fail, well, I just made a mistake and just need to go and review them, okay? So this is always a good practice. Cool, we have our script tested. So let's start working on the pipeline. So first of all, I'm gonna start by defining this cache configuration here. So SageMaker supports, or many components, many steps in a pipeline, in a SageMaker pipeline, support the idea of caching. And it's crucial, this is really important. The whole idea is, if nothing has changed from the previous time you ran that pipeline, if nothing has changed, then SageMaker is not gonna rerun a step. Instead, it's going to use the last successful run of the pipeline. So let's imagine that we want to train our model, and we first pre-process the data, and then we train our model. And let's say the pre-processing step takes 1 hour to run because it's a large data set. And then we train the model, which is another hour. And you realize after training the model, you realize, you know what, I want to change the training process. I want to change a hyperparameter here. You make a change in the training step and you rerun the pipeline. Well, you don't want the pre-process to happen again. Nothing has changed in the pre-processing script. The data has not changed. It doesn't really make sense to rerun the pre-processing step. If you have caching enabled, then SageMaker will reuse that the results of the first or the last pre-processing run, and then it will only repeat the training step, which was the one that changed. So that is really, really important to have. I'm enabling caching here. and I'm saying the cache should expire after 15 days. So as long as I'm executing repeated runs of the pipeline within 15 days, then I can use cache. Cool, awesome. So after doing that, the next step is to define the configuration of my pipeline. Here's the idea. I started by telling you this. We want the ability to point our pipeline to the location of the data in S3 and say, hey, run the pipeline on this data set. So in order to do that, we need to use a parameter for the pipeline that specifies where the data set is located. So I'm going to create a parameter. It's a parameter string. That's the class that you need to use to define a parameter for a pipeline. That's going to be called dataset location. And anytime as part of the pipeline that I want to reference the original data set, I'm going to do it through this variable here, or through this parameter, which is called dataset location. Really important, because anytime I do that, I can later change or rerun the pipeline with a different value without having to change anything. Now, how do you use this in a real application? Here is one example. Imagine that you have a data set with a bazillion rows, okay? It's just a huge data set. And you're testing out something new in your pipeline. And you want to run your pipeline. You want to make sure your pipeline runs, but you don't want to process that many rows on your data set because it will take 2 hours to run. So you can have a separate folder with just a few samples and run your pipeline by just changing the location of the data, pointing the pipeline to the smaller data set. The pipeline, you can test the whole pipeline really, really quick without having to deal with the whole data set, with the bazillion row data set. And you can do that through the parameter here. So that's what I'm doing here. I'm creating this parameter. Again, the name is dataset location, and I'm defining a default value so I don't have to specify it every single time I run the pipeline. And the default value goes to S3 location, which is the variable that we define in session 1. What is the value of this the variable? Let me just type it here. Is S3 ML School. This is the name of my bucket. Your variable is going to have a different value because you're going to have a different bucket name /penguins. So that's the name of the variable /data. That is the location where we stored the CSV file in session 1. So that is the definition of that parameter. There is a different variable here, which is called the pipeline definition config. This is actually not interesting. This is just for me to allow me to use custom job prefixes. If I don't use the pipeline definition config, I get a bunch of warnings from AWS. Again, not interesting. Anytime I create a pipeline, I'm going to pass this configuration here. All right, so this is all of the setup that we needed to do what we really need, which is the processing step. Define the first step that is going to be pointing to the script that we created. This is the processing step that we're going to be creating. And I have a little diagram. I'm actually going to go here to the website. It's probably easier to see here. We're in step 3. So let's go down. Let's click here so we get like a larger view of this graphic. This is just so you can see what's going to happen behind the scenes. When we run the pipeline with a processing step, which is the name of the component that we're going to use, what is going to happen is that internally, SageMaker is going to create a cluster and it's going to run multiple instances in case we have multiple instances on our processing step. We only have one, but it will create one instance where it will deploy a processing container. So it's just a Docker image that we need to specify which Docker image we want to use. SageMaker is going to deploy that Docker image in that computer, in the cloud, inside that cluster. There's going to be an input directory where SageMaker is going to grab every single thing from that. By the way, this arrow here is the other way around. This arrow here, there is a mistake in this arrow. It goes the other way around if you're looking at this recording. So the data on the S3 bucket, SageMaker is going to copy that data over the input directory of my processing container. It's going to run the script that we created within that processing container. And when it finishes, it's going to grab anything in the output directory and it's going to upload it to S3 as the outputs that we are going to get out of this processing job. This is what happens behind the scenes. If we run multiple instances in parallel, then this cluster, like these yellow columns, are gonna be just multiple instances running the same script and running the same process. And one of the assignments is how to do this. I think I talk about that as part of the live sessions, but one of the assignments is for you to configure like a multi-instance processing step. But yeah, here we're just gonna use a single instance. All right, so let's take a look at what this looks. So for us to run the processing step, we need to specify, we need to tell SageMaker what is the Docker container that SageMaker should use to run our script. Our script, if you remember, we're using scikit-learn. That is the main library that we're using. So ideally, we want to tell SageMaker, hey, we want to run our script on a container that supports scikit-learn. That container should install all of the libraries that are required for us to run our script. We're using NumPy, we're using Pandas, scikit-learn. So we want a container that supports that. The good news is that SageMaker already have a bunch of pre-created containers that we can use. And there is a link here. I'm going to click on this link. There is a link here that is going to take you to a page listing all of the containers that we already have access to. So if I look here, I should have it here. Let's see. Scikit-learn. Do we have scikit-learn? We don't have. These are the deep learning containers. So scikit-learn is not here. We're gonna have to. These are PyTorch, TensorFlow, NVIDIA, Triton, Gloom. Let me see. Hugging Face. Yeah, these are the deep learning containers. Let me search for SageMaker, scikit-learn, containers. Let's see. Pre-built Amazon SageMaker Docker images for scikit-learn. Okay, so SageMaker scikit-learn containers. Let me click here. Let's see the names. I just want to see the names. I don't find the page right now. I'm gonna find the page and make sure I update the notebook. But here is the 1.2.1 Docker image. I've just got to the source code. And if I go to the base, yeah, this is the Docker file. And again, this is just a Docker file. The official image that SageMaker uses is called the SageMaker scikit-learn container image. Just the official image that they use that we can use to run our code. Now, there are two ways that you can specify this Docker container. One way is you use like a base class that SageMaker offers, where you individually specify, I want this image with this version, running this version of Python. You specify all of that, and SageMaker goes and grabs that image, and it runs that image automatically for you. Or, luckily for us, SageMaker also offers, maybe here, let me see. Well, these are TensorFlow and XGBoost. Gosh, I didn't get any of the links. Scikit-learn. Let me look it up here. Scikit-learn, SageMaker SDK, sorry. Okay, there we go. So luckily for us, SageMaker provides high-level classes that internally, those classes will take care of selecting the framework for you. That is what I'm going to be using in my code. So this is the SDK, the SageMaker SDK, and I'm gonna be using in my code an sklearn processor class. Again, this is the class that you use when you want to use a processor, a container that supports scikit-learn. And lucky for us, that container will also have Pandas and NumPy because those are standard machine learning libraries. All of these containers already have access to them. So this is the class that I'm using here. Now this is the processor. I'm creating the sklearn processor. You need a processor to create a processing step. The base job name, this defines the job name that you will see in SageMaker. When you go to SageMaker here, if I go to SageMaker, the page of SageMaker, there is a processing tab. Click on the processing jobs, and you're gonna see a bunch of jobs here. See, pre-processed data. That's a job. pre-processed data. This is the name of the job. So you can find here in the processing jobs any one of those jobs that run before, and you can identify them by that tag. That's just the base job name. SageMaker will add something after that. We'll add the 1TK, whatever. But the process data is sort of like the prefix of that. Framework version. I'm using the sklearn processor class. I need to tell SageMaker which version of the scikit-learn I'm going to be using. And I'm going to be using 1.2-1. There is a bunch of other versions. This is the latest one as far as I know so far. So this is going to be giving us access to the latest version of scikit-learn in SageMaker. Instance type. What type of computer do I want to use? Remember that in session 1, we created the config dictionary. So if I do this, if I run this, this is going to tell me that we're going to be running the code with ML M5 XLarge. That is the type of computing power that I'm requesting SageMaker to provide for me. So SageMaker is going to create an instance with those hardware characteristics, that amount of memory, the CPU, how many virtual CPUs, etc. I'm going to be using that type of computer. If you don't have access, if you're watching this session and you still don't have access to ML M5 XLarge computers, you can just replace this by MLT3 Medium. The MLT3 Medium is a smaller computer, so has less hardware than the ML M5 XLarge. You can use the ML3 Medium to run the processing job. So you can get over this session, you can finish it without having to request access for the XLarge. However, it's going to take way longer to finish. An MLT3 Medium, I think, is going to take like 13, 14 minutes to finish, while this processing job will take 5 minutes with the M5 XLarger because it's a much better computer. So anyway, just so you know, you can do that here if you don't have access to the ML/M5. So this specifies that instance type. This specifies how many instances do I want. Remember, it creates a cluster and it's going to run within that cluster all of the instances. In this case, I just want one instance just to process the data set. If you had like a bigger data set and you wanted to parallelize the processing job, you wanted to create multiple jobs at the same time, you could specify more instances here. What is the role that this job is going to be running under? Remember, this is the role that's coming from your environment variables. This is sort of like defines the permissions that SageMaker will assign to this processing job. We already have that variable. We're just specifying that variable. And this is the session that we're going to be running this under. We are here using, let me just see what value we have here. Let me print out this. So this is using a pipeline session here. So it's using a pipeline session because local mode is probably false. Exactly. So I have this set up local mode in false. So if I run my pipeline, this is going to run in the cloud. I'm going to change that in a second. I'm going to first run it locally so you see the results. When I'm running in local mode, I will have like a local pipeline session. Remember, we saw that in session 1. Because local mode is false, I'm setting up this session as a pipeline session, telling SageMaker, whenever you run this processor, whenever you call the run function of this processor, do not execute it immediately. Instead, wait for the pipeline to start. So just, if I call run, and this processor is running on a pipeline session, SageMaker is not going to execute anything. You're going to see that in a second right now. Just make sure that you understand that. All right. So we defined the processor. Final step before we just create the pipeline is just defining the processing step. This is the step that we add to the pipeline. And the processing step requires a processor. That's what you are going to see right here. It's just a weird way to set it up. But notice the processing step, a name of that processing step. You're going to see that name when you visualize the graph of the pipeline. We're going to see the pre-processed data name. Then you specify what are the arguments of this step. And what you do is you call run on the processor that you just defined. And again, as I said before, because this processor is configured using a pipeline session, this run function is not going to execute the processing job. It's just going to take a look at all of the configuration, set it up, but it's going to wait for the pipeline to execute before the job runs. If I were using a SageMaker session, calling run will immediately execute my job. That's not what we want here. All right, so let's see what's inside the run function. First, I need to determine what the code is. Like what is the script? Okay, what code do you want to run as part of this processing job? Well, I'm just pointing to the script file that we created. Here's the script file. Remember this whole script file? So I'm just telling SageMaker, please execute this script file. When you run, execute that script file. Then I need to define the inputs to that processing job. And in our case, the inputs are just the data set, just the location where the data is going to be. So notice that I'm passing here, when you create an input, you specify the source of that input. So what is the data that you want to pass? That is the dataset location, which is the parameter, the pipeline parameter that we define. That way I can change that value without changing anything in my code. And what is the destination? Like, what are you going to do with that input? Okay, where are you going to save that input? Because this is a location in S3, the destination, I'm just passing a folder, which is the OPTML processing /input. And SageMaker will automatically download anything from this location into this location. SageMaker will take care of that, okay? Remember the little chart, this chart here with the arrow that is supposed to go the other way around. SageMaker will automatically copy the input from S3 into the processing container, into that location. That is what SageMaker is going to do. Cool, that's the input. Now I need to specify the outputs. So you do that using the processing output class and look at all of the outputs that we have. We have plenty of stuff. So let's go one by one. The first one is the train set. Remember, that's one of the things that our processing job does. So I specify, well, the name is train. The source, in this case, the source points to the path, the folder structure inside the processing container. So the train get it from here, from this location, and save it in my bucket in S3 at this location, preprocessing /train. Save it there. I'm doing the same thing with validation, getting it from one location, just specify the source and the destination. Get it from here, save it here. Get it from here, save it here, right? The test set. By the way, you don't need to specify the destination. If you do not specify a destination, SageMaker will automatically pick a folder and save it there. But I want to have control where the data is saved. Therefore, I'm asking SageMaker to always save it on the same destination. If you were working on a potentially real application, maybe you don't want to specify a destination, because what's going to happen is every time you run the pipeline, you're going to be overwriting the files from the previous runs of the pipeline. So if you want to keep history and you want to keep every run of the pipeline separate, you don't want to specify a destination, or at least change the value of the destination every time you run your pipeline. But in this case, I'm just specifying a fixed destination. Processing output model. Remember that we're saving the transformation pipelines inside a model.tar.gc file that we're creating. So I also want to save that in this location here. And finally, the train baseline and the test baselines, which we are also creating and saving. I'm also uploading them as outputs of this processing step. So a bunch of stuff, just a step that runs, I pass a data set, I get a bunch of outputs, and SageMaker will take care of downloading the input data, running the script, and grabbing the output data as I specified here and uploading that to S3. Final thing, I pass the cache configuration, so I make sure that this step is cached. Pretty good. All right, final thing that we need to do is just create the pipeline. We just need to create the pipeline and run it. How do I create a pipeline? I'm going to use the pipeline class. I'm going to give it a name, session 3 pipeline. We're in session 3, so this is going to be session 3 pipeline. I need to specify a list of parameters In this case, the only parameter that we have is the dataset location. That is the parameter that we define. I need to specify a list of steps. In this case, we only have a single step that's going to pre-process the data. I pass the pipeline definition config, which is the variable that we defined before, and I pass the session, which is going to be the same pipeline session. This is the definition of my pipeline, and here in this line, I'm going to upsert that pipeline. In other words, update if it already exists, or insert if it doesn't exist. So this is sort of like registering the pipeline, telling SageMaker, hey, here is a new pipeline that you should be aware of. I need to run the pipeline right now. In order to do that, I'm going to go to session 1 because I want to run this pipeline locally here on my computer so you see it running. I'm going to go to session 1 and I'm going to change local mode to true. This is what you need to do in order to execute all of the code that we've seen so far. I'm going to go back to session 3, actually, last step of session 3, which is where we create that pipeline. Now you can click on this button right here. You see this little button right here? It's called execute above cells. If you run this, this is going to run from your notebook every single cell above the one that you're standing on. I assigned a keyboard shortcut to do this. So if you hover over this button, you're gonna see that the keyboard shortcut is Control Command E. Feel free to do the same thing. You can remap that if you want to. So I'm going to run that, and that is going to run every single cell of my pipeline, of my notebook, right now with local mode equals true. So when it finishes, it already did. I'm going to, look at this. See how this warning, this is just stupid warning. This warning that I'm getting here tells me, let me scroll, it says, running with a pipeline session, there will be no wait, no logs, and no job being started. So this is SageMaker over communicating and telling me that because I configured my processing job using a pipeline session, it's telling me, hey, just so you know, when you call the run function, this is not gonna run, okay? Nothing is going to happen. I know that's the goal. So anyway, they just show that warning. You can just ignore that warning is what we want. All right, so let's execute this line. When you're running in local mode, notice that this is what you're gonna get back. The pipeline Amazon resource name is just gonna be the name of our pipeline. And now we can run our pipeline. Let's say it running. How do you run a pipeline? I created here in this notebook at the end of everything, right? So I'm gonna open it up. At the end of everything says run in the pipeline. There is one cell to run any pipeline you want, okay? You just need to change the name of the pipeline. And I did that here so I don't have to repeat myself under every single session because it's just too much for nothing. In order to run this pipeline, notice that if I try to execute this cell, nothing is going to happen, okay? And nothing happens because I have this line here. And the note explains what's going on. I don't want anybody by mistake to run a pipeline. So I have this line here to disable this cell. But if you comment out this line and I execute now, I'm calling the start function of the pipeline. So I'm gonna do that, and this is going to start running my pipeline. Now remember, we are running in local mode, which means SageMaker, or this engine here that's running, is going to download the scikit-learn processing container from the internet to your computer, and it's going to run it and run the script within that SageMaker container on your computer. This is done and it succeeded. You can see here that that step succeeded, so everything worked. But it was so fast because I already had the container here on my computer. The first time you run this, it's going to take longer because it has to download that container. The second time, now it's gonna be faster. All right, so let me see here. Am I printing anything within that job? I am not printing anything. That's fine. But hey, pre-processed data succeeded. I'm gonna call that a win. So that means that my pipeline ran locally and it executed that processing job and everything was good. Now let's run it up there in the cloud. I'm going to go back to session 1 and I'm going to change this local mode. I'm going to change it to false. Okay, so I'm going to change that to false. I'm going to go back to this cell. I'm going to execute everything. I want everything to be initialized, assuming local mode is false. So this is running. It's just going to take a second here to finish. You're going to notice now when I execute this cell, the creation of the pipeline, that the output is going to be different than this, okay? It's going to be more verbose. Look at this. I'm going to execute this cell now. Boom, I get much more information. So that tells me that this pipeline was created, was registered in SageMaker. So I get like a full Amazon resource name back. That's the name of my pipeline, metadata. I get a bunch of stuff. Let's run it now. Let's go back to running the pipeline and execute the same line. And now I should get just a single line telling me, hey, this is running. So I just run it. Let me go back here. You get pipeline execution of this name, yada, yada, blah, blah, blah. So what happens now? Now we go to SageMaker Studio. Remember session 1, we saw SageMaker Studio. Let's go there. Inside SageMaker Studio, you're going to go to pipelines. And now you're going to see there your session 3 pipeline. And if you click on session 3 pipeline, you are going to see your pipeline. And in this case, the blue color means this is executing. You can see it here. This is executing. So now we are running this job. Let's go to the list of processing jobs. Do we have it here? Look at this. This is the pre-processed data job, a duration, it's been a minute and is in progress. So we have a processing job that's running in the cloud right now. It's going to take about 5 minutes to finish. While that finishes, let's click here and you can see all of the data related to this pre-processed job right here in the SageMaker view. So for example, if I go to settings, you're going to see this is running on an MLM5X large computer. What else do we have here? We know that it's 30 gigabytes in the hard drive. We can change that in code. If you need less than 30 gigabytes, you don't need to use 30. You can use 5 or whatever. You can change that. Here is the image that we're using to run this. This is the name, like the location of that Docker image. Notice is a weird account number, AWS account number, and the name of the image is SageMaker, scikit-learn 1.2-1-CPU-Python 3. That's the name of the image that SageMaker picked for us. It picked that because we used the sklearn processor class and we specified that version number. So SageMaker picked that for us. What else do we get? This is the entry point or the script. What else do we get? So there is a bunch of data, obviously, local path. Let me see. What else? The code that we're going to be running. What are the outputs? Well, here are the outputs. Like, for example, output name is train, and it's going to be saving that in this particular location, S3 ML School Penguins Preprocessing Train. And the local path where it's getting that output from is OPTML Processing Train. What else do we have? Second output is validation. So you can see how you can get all of the information of the processing job from here. That is awesome. So as you can see, you can get all of the information that's related with this processing job, which by the way, already finished running. You can get it from here, from your pipeline view. So this is done. You can see how it's green, is succeeded, which is awesome. What's really cool is if I re-execute this pipeline, let me show you this really quick. I'm going to go back to session 3 pipeline. So see, this is the last one that we run, 774. I'm going to go back to my code and I'm going to restart the pipeline. Hey, just do it again. And notice what's going to happen. So if I refresh this list, I'm getting A48 and it already succeeded. It took 3 seconds. The reason is because this pipeline hit the cache. So we got a cache hit. By the way, SageMaker changed the whole studio. I'm not quite used to this studio now, but there's somewhere here, there should be an indication that this pipeline comes from there we go, cache hit result, and it gives us what the hit was, which is the previous pipeline. That's exactly where we got that information from. So the second time I rerun this pre-processing job, it didn't run, it just reused the previous results. One more thing before we're done, let me show you the S3 contents after running my pipeline. So I'm gonna go to my bucket, and there is a bunch of stuff that I have here in my bucket. So apologize about that. Actually, I need to go inside. Okay, there we go. Penguins. I need to clean my bucket here. But you're gonna see inside the Penguins folder in my bucket, there is a data folder, which is where we uploaded our data set. But there is a pre-processing folder, which is the one that we are creating when running the processing job. And that is how every single folder that we created as part of the outputs is here. The model one contains the model.tar.gc file, which is the transformation pipelines are compressed inside. The train contains the train CSV. Look at this. Let's download this. So I can show you exactly what's going on. So if I go to downloads and I open this file, I'm going to try to open this. Can I open it in? No, I cannot open it in. I tried to open that file with the browser. Didn't work out. That's okay. I'm going to open it with this application, make it a little bit bigger. This is my train data. Notice how all of the data is transformed. So I'm not longer using the original data set. I'm using transformed data. Look at these final values here. See how it says 1.0000002.0? Well, the final column is the target. So this penguin is penguin 2. So I think that's change trap. And then these three values here, this is the one hot encoding, these three values. This is the one hot encoded version of the island. So it's 100. This is another island, 010. See that? This is what you get on that S3 bucket. So hopefully this helps. The stuff that we saw today as part of this session, you're gonna notice a pattern. And as we define a training process and as we define other processing steps, you're gonna find that we're gonna be repeating the same thing. We're gonna be creating a script. We're gonna be defining the container that we want to run that script on. We're gonna be adding those steps to the pipeline. So it's going to become easier as we move forward because we are covering, basically we're learning how to do these things with SageMaker. Nothing else, I'll see you in the next session.